So today's topic is Cauchy sequence. Cauchy sequence is a very important part in the context of sequence chapter. But though I am writing Cauchy sequence, actually it sounds like Cauchy sequence of real numbers because we are dealing with this course the sequence of real numbers only. But it is not like that we don't have a sequence of complex number, but that is not now included in your syllabus. It will be on the scope of your syllabus. So we'll get to know about sequence of complex number later on. But now for time being it is called Cauchy sequence of real numbers. A sequence xn of real numbers is said to be a Cauchy sequence. A sequence xn of real numbers is said to be a Cauchy sequence if for any epsilon greater than 0 there exists a positive integer n such that modulus xm minus xn is less than epsilon for all m comma n greater than n. A sequence xn of real number is said to be a Cauchy sequence if for any epsilon greater than 0 there exists a positive integer n. This integer n must be dependent on this epsilon such that the difference between xm and xn is less than epsilon whenever this m and n both are greater than n. Usually we always used to choose m is greater than n and that is greater than n. Usually this is the usual concept, but the actual definition stands like this. So if m is greater than n, so if I subtract xm from xn, then first n number of terms will be deleted from this xm term. The point is something like this. Suppose we have x1, x2, x3 continuing this way xm, and x1, x2, x3 continuing this way xn. Since we are deleting xm from xn and m is greater than n, there will be n somewhere in between before m. Since m is greater than n, there will be n before m. So those n terms from this term will be deleted after subtraction. The point is, since m is greater than n, so before m there will be n somewhere over here till those terms will be cancelled with these terms while doing the subtraction. So after subtraction the term starts from n plus 1 till n term it will gone. So it will start from n plus 1, n plus 2 continuing in this way n plus p. If we replace m by n plus p. Now what is p? P is a natural number starting from 1, 2, 3 dot dot. That means after subtraction we'll start with n plus 1, n plus 2 continuing this way n plus p. This is the concept of choosing n usually greater than n, and that is obviously greater than a certain natural number capital N which is depend on this choice of epsilon. This inequality 1, or let's say this inequality, is known as Cauchy criterion. Now let me elaborate this concept of Cauchy sequence with few examples. The first example stands with the affirmative sense. Affirmative sense means first example gives you the answer yes. The answer example is sequence 1 by n is a Cauchy sequence. The sequence 1 by n is a Cauchy sequence. For this, let us take positive integers m, n such that m is greater than n. I am choosing two positive integers m and n such that the first one is greater than the second one. Then, as you know, here also I consider m greater than n. We have to show this is a Cauchy sequence. So first calculate this difference xm minus xn. What is xm here? Here xn is 1 by n. So xn is 1 by n means xm is 1 by m and xn is 1 by n. So take the LCM, it will be mn then m minus n. What I choose over here? M is greater than n. M is greater than n means this difference is positive. This difference is positive and m and n both are natural number. So we can withdraw this modulus and write it in this way, 1 by n into this. Now as you know, this is a greater than 0 quantity but less than 1. Greater than 0 quantity but less than 1. It is shown over here. Since m greater than n, this implies this ratio is greater than 1. This implies after taking reciprocal, it is less than 1. So this term is greater than 0 but less than 1. That therefore this difference is less than 1. This difference is less than 1. So this product into this the term less than 1 means this product is less than 1 by n. Now if I choose this is less than epsilon, That means this quantity is less than epsilon. This difference less than epsilon if this 1 by n is less than epsilon. That means n is greater than 1 by epsilon. Now to justify the definition, we need a natural number capital N, and this 1 by epsilon will be treated as this capital N natural number. But as you know, epsilon is just a positive quantity, so its reciprocal may not be maybe its reciprocal is positive, obviously positive, but may not be a natural number. So to get a natural number or to get a positive integer, it's better to take its box. So if we choose its box, that means the integral part, then we'll get an integer over here, positive integer, and we can say this difference is less than epsilon when this m greater than n greater than this capital N natural number, and this natural number stands for this integral part 1 by epsilon. That means this difference is now less than epsilon for this natural number n. That means our claim is established that this sequence is a Cauchy sequence. This sequence is a Cauchy sequence. Now, example 2. This example gives you the negative answer. The example is the sequence n square is not a Cauchy sequence. The sequence n square is not a Cauchy sequence. For that, again you choose m greater than n. Then m square minus n square will be, because xm minus xn will be here, m square minus n square. And m square minus n square is m plus n into m minus n. Again, as you know, m greater than n means their difference is positive. So their difference is positive means this quantity is positive. This quantity is already positive because both are natural number. So product of these two obviously greater than one of them, like this, m plus n. Now m is greater than n, so this quantity is greater than n plus n equal to 2n. Now what is n? N is natural number, and natural number starts from 1. So this quantity is obviously starts from 2, then 4, then 6. So it is greater than 1, obviously. So this modulus is greater than 1. That means we can't let this modulus less than any however small positive quantity epsilon, because eventually this modulus becomes greater than 1. That means this is less than epsilon for this. Therefore this is not a Cauchy sequence. Now let me establish few applications of Cauchy criterion. The application is, again, I'll give you two examples. One gives you answer negative, another gives you answer positive using Cauchy criterion. Now what is Cauchy criterion? This difference less than epsilon, this itself is a Cauchy criterion. That means if I use Cauchy criterion to establish a sequence convergent or not convergent, that means I am giving you the answer the sequence is Cauchy or not. তোমরা যদি Cauchy criterion ইউজ করে কোনো সিকোয়েন্স কনভার্জ হচ্ছে কি হচ্ছে না দেখাও, তার মানে তোমরা অ্যাকচুয়ালি দেখাচ্ছ কি যে সিকোয়েন্সটা Cauchy. If you use Cauchy criterion to show whether a sequence converge or not, actually you are showing the sequence is Cauchy or not. This is the actual point over here. Now use Cauchy's criterion to prove that xn does not converge. That means I'll give you the negative answer for this, where xn is this 1 plus 1 by 1, 1 by 3, 1 by 4, 1 by n. So how to prove this is not convergent? Assume the contrary. Assume the contrary means ধরে নাও যে এটা কনভার্জ করে, কোথায় কনভার্জ করে? একটা ফাইনাইট লিমিটে কনভার্জ করে. Suppose this converges to a finite limit. Then by Cauchy criterion I can choose the epsilon according to my choice, let's say half. And there exists a natural number like this which will satisfy the condition like this because it is a Cauchy sequence. Now choose m greater than n, and that is greater than or equal to natural number. Now as I told you, since m greater than n, if you subtract xm from xn, the difference starts from n plus 1, n plus 2 dot dot xn. Now xn plus 1 is 1 by n plus 1, xn plus 2 is 1 by n plus 2, xm is 1 by m. Choose m equal to twice n. Choose m equal to twice n because m is greater than n. Since m is greater than n, I can choose m according to my choice. So choose it as 2n. Now 1 by n plus 1, 1 by n plus 2 and 1 by 2n is greater than n into 1 by 2n. n into 1 by 2n. Why it is n into 1 by 2n? Because look, n plus 1 is greater than n. So 1 by n plus 1 is less than 1 by n. Sorry, n plus 1 is greater than n plus n. N plus 1 is less than n plus n. Then 1 by n plus 1 is greater than 1 by 2n. Similarly, 1 by n plus 2 is greater than 1 by 2n. 1 by n plus 3 is greater than 1 by 2n. So ultimately, there are n number of terms over here which are greater than 1 by 2n. So n cancel, ultimately half. So this sum is greater than half. But I assume this is less than half. So which is a contradiction. Why this contradiction? Because I assume this sequence convergent. So ultimately, this sequence become divergent. This cannot be convergent. This inequality clear? N plus 1 is less than n plus n. That means this, after taking reciprocal, it will be greater than 1 by 2n. And there are n many terms over here. So this is the application. Now the yes part. That means another example which gives you the affirmative answer. Use Cauchy's criterion to prove that yn is convergent, where yn is 1 plus half factorial, 1 by 3 factorial, 1 by n factorial. This is yn. We observe that, look, 1 by n factorial means one by n factorial means 1 by 2, 3, 4, dot 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 n. Now as you know, 1/3 is less than half, 1/4 is less than half. In this way, all this term is less than product of 1 by 2 dot 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 2, because 1/3 is less than half, 1/4 is less than half, 1 by n less than half. But how many terms over here? N minus 1 terms. Why? Because the first term is missing, 1 is not there. So we have n minus 1 terms over here. So after multiplication, it will be 2 to the power n minus 1. So we got an interesting inequality which gives you that 1 by n factorial is less than 1 by 2 to the power n minus 1. 1 by n factorial is less than 1 by 2 to the power n minus 1. Now consider m greater than n, then then ym minus yn again starts from yn plus 1, since m is greater than n, so this difference starts from n plus 1, n plus 2, continuing m. What is yn plus 1? Yn plus 1 will be 1 by n plus 1 factorial. Yn plus 1 will be 1 by n plus 1 factorial, and by this inequality, it is less than 1 by 2 to the power n. This is less than 1 by 2 to the power n plus 1. This is less than 1 by 2 to the power m minus 1. Then if I choose 1 by 2 to the power n as common, I get a GP series, finite GP series inside. So I can apply the sum of the GP series concept over here. Then I got this. This is less than this quantity because 1 minus something is less than 1. So again 1 by 2 is 2. So this quantity will give, ultimately this difference is less than 1 by 2 to the power n minus 1. And as n tends to infinity, this will tends to 0. That means I can make this term less than a positive quantity epsilon for a natural number n naught. And if this is less than epsilon, ultimately this quantity, this difference is less than epsilon for all n greater or equal to a certain natural number. That means Cauchy criterion is satisfied over here, and we can say yn converges to a finite limit. So one gives you a yes answer, another gives you a no answer. These both the examples are very important. Now Cauchy's first limit theorem. If the sequence xn has a limit L, then the sequence yn, where yn is the arithmetic mean of the first n terms of this sequence. This is a very interesting result which states that if xn is converges to a limit L, then if I take the arithmetic mean of the first n terms of this sequence, arithmetic mean of the first n terms of this sequence, and consider a new sequence, then that sequence will converge to the same limit. Now, how does this sequence looks like? The first member y1 is x1. The second member y2 is x1 plus x2 by 2. The third member y3 is x1 plus x2 plus x3 by 3. So these are the these are the elements of this new sequence yn, and these are the structure of the new elements, actually the arithmetic mean. So if xn converges to L, then the arithmetic mean also converges to the same limit L. And as a corollary of this theorem, we can say that the geometric mean also converges to the same limit. As a corollary of this same theorem, we can say that geometric mean is also converges to L. Now step 1, let L equal to 0. First consider the limit as 0. Then given any epsilon greater than 0, we'll find a positive integer like this, such that this minus 0 because L is 0 less than epsilon by 2. Here I use normal sequence convergence criteria. Then modulus this epsilon by 2. Now what is yn? x1 plus x2 plus dot dot xn. Now as I said here, n is greater or equal to m. So before n we have m. So x1 plus x2 plus dot dot xm, then xm plus 1, then xm plus 2, then xn by n. So I can separate this sum as till m one term, one part, and after that one part. I separate this sum as like this, till m one part, after that one part. Now take the modulus, then it will be modulus of this plus this part plus this part, and use the triangle inequality, which says that this part plus this part is less or equal to this part plus this part. Since m is fixed, this term is less than epsilon, because till m we can use this inequality. Since m is fixed, this whole quantity is less than epsilon. And since m plus 1, m plus 2, each of them, since m is fixed, we can choose n1 such that this plus this whole is less than epsilon by 2. And each of this modulus xm plus 1, xm plus 2, this is less than epsilon by 2, this is less than epsilon by 2, this is less than epsilon by 2. But how many terms over here? Till total n minus m terms. Here we have from m plus 1 to n, we have n minus m terms, and each of them is less than epsilon by 2. So altogether this quantity is less than epsilon by 2 into n minus m, because total n minus m terms are there and there is a n in the denominator. So I got a natural number n1 over here, and I got a natural number m over here. I got our natural number m here, and I got a natural number n1 over here. Now I choose their maximum, and if n is greater than their maximum, then I can say this modulus, which is a part of this two mod, one is this, another one is this, is less than epsilon by 2 plus epsilon by 2 into n minus m by n. Altogether epsilon by 2 plus epsilon by 2 is equal to epsilon, which says that this also tends to 0 as n tends to infinity. Step 2 is similar. If L not equal to 0, then xn tends to L, means this difference tends to 0. This difference tends to 0. Xn tends to L means its difference tends to 0. That means we can now take the sum like this: x1 minus L, x2 minus L, xn minus L by L equal to yn minus L tends to 0. That is yn equal to this sum by n tends to L as n tends to infinity. So if L not equal to 0, then also this limit tends to L as n tends to infinity. Now let's finish the topic till this. Once you understood the whole topic, I'll give you some exercise to solve.